Hey, Mr. Midas here, and in the last video we talked about Taylor and Maclaurin polynomials. So if we take a Taylor and Maclaurin polynomial, we can also extend it to called a Taylor and Maclaurin series, and we just talked about that if we extend that to an infinite series, then we're able to get a good, not just a good, but an exact correct approximation to the transcendental function, and we in the last case we used f of x equals e to the x. So given that the f of x has derivatives of all orders, so that means it could just be derivative the whole time, we could take and find a Taylor series using the same formula that we used before for the Taylor polynomial, only we're going to extend it out to infinite. And we could do the same thing for the Maclaurin series. So I have them here on the screen. And these formulas can form a power series. It could be written as a geometric power series. So let's take a look at a few examples of using a Taylor and Maclaurin series, using the polynomial and then turning it into a series for a couple of transcendental functions. And in this case, I will use a different center. This time we'll center it around a different c instead of 0, which will be a Maclaurin series. We're going to center this one around pi, because why wouldn't we center things around pi, right? Pi is good. F of x equals cosine x centered at c equals pi. So let's go ahead and take a look at this. For all of these, we're going to start with cosine, or we're going to start with f of x, and then we're going to take the derivative, negative sine. Then we're going to take the derivative again, negative cosine. Then we're going to do what? Take the derivative again. And then we're going to take the derivative again. Now, the question asks for the fourth order Taylor polynomial, so we're going to stop there. Plug in pi for each of these. So the cosine of pi is negative 1. The sine of pi is 0. The cosine of pi is negative 1 times negative 1 is 1. Sine of pi is 0. Cosine of pi is negative 1. You see that we're going back, right? It's repeating itself. So we're going to do this fourth order Taylor polynomial. And again, we're going to start with f of pi, so negative 1, plus f prime of pi times x minus pi, plus f double prime of pi times x minus pi squared over 2 factorial, plus 0 f triple prime times x minus pi cubed over 3 factorial, plus, I think I forgot my negative 1 here. No, that was positive 1, that's right. Negative 1 times x minus pi to the 4th over 4 factorial, right? Okay, we'll reduce that down. That's negative 1, the 0 is away, plus x minus pi squared over 2 factorial. We don't need this one, minus x minus pi to the 4th over 4 factorial. Now, this one's asking for f of x here. So f of x is the Taylor series. We're going to have to go on forever. Let's put one more here. And we'll go dot, dot, dot. Even though we know it's going to alternate negative, positive, we'll still put a plus there so we can do our dot, dot, dot. Okay, so there is the Taylor series. Now, this Taylor series represents cosine x. So, in my next example here, we want to use the Taylor polynomial that we just got, the Taylor polynomial, so the 4th degree polynomial, to approximate cosine of 3. So cosine of 3, we're going to use the Taylor polynomial now, the Taylor polynomial. So we're going to have negative 1 plus 3 minus pi squared over 2 factorial minus 3 minus pi 4 factorial. Okay. And we'll go ahead and plug that in our calculator. And we're going to get negative 0.989857. And that is an approximation. Now, cosine of 3 is actually negative 0.98999. But this is close. It's an approximation. And we're out to the 4th degree, and we're already pretty, I mean, we're only off on the 4th decimal, hundreds of thousands. So it's a pretty good approximation. Let's take a look at the next one. We've got a Maclaurin series now. And we'll use a Maclaurin series to approximate f of x equals sine of x. All right. Again, we start with sine x, and then we take a derivative, and then another derivative, and then another derivative, and then another derivative, and then another derivative. So keep taking derivatives. Now we're doing a Maclaurin series, so we don't actually have to go out 5 terms or to the fifth degree, but we need to go as far as we can so that we can see what's going on. Oops. F prime of 0 is 1. F double prime of 0 is 0. Negative 1, 0, and 1. All right, so let's go ahead and use this stuff here to come up with our series. So we're going to start with 0 plus 1 times x plus 0 times x squared over 2 factorial minus 1, because that's negative 1, x cubed over 3 factorial plus 0 times x to the 4th over 4 factorial plus 1 x to the 5th over 5 factorial plus dot dot dot. Okay, so what's that actually look like? I got another example here in my way. Let me write it up here. Let me simplify this out. So f of x equals sine x is going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. You see why I went out to 5 now. Minus x to the 7th over 7 factorial plus dot dot dot. Let's go ahead and write this in sigma notation. I need at least the nth term, so we're going to go negative 1 to the n minus 1, x to the 2n minus 1, all over 2n minus 1 factorial plus dot. Okay. All right, so this right here is the Maclaurin polynomial, the Maclaurin series for sine x. Let's take a look at our last example here. Find a power series for f of x centered at c equals 1 if f of 1 is 2 and f of the nth derivative of 1 is n factorial. So what do we know? We know that f prime of 1 is equal to 1 factorial, which is just 1. We know that f double prime of 1 is equal to 2 factorial. Now I get that. How do I get that? This is 2 dashes, right? So 2 dashes here will give me 2 factorial here. F triple prime of 1 is 3 factorial. F fourth of 1 is 4 factorial. F5 of 1 is 5 factorial. So again, what I'm doing here is I am just building the little table that I had in the previous one. I just don't have to take any derivatives. I just got to follow this derivative rule here. Now I'm going to go ahead and set up that series. So it's going to start. We're always going to start with the first one, term 2, plus f prime of 1, which is 1, times x minus, where is it centered? It's centered at c equals 1, x minus 1, plus 2 factorial over 2 factorial times x minus 1 squared, plus 3 factorial. Where am I getting these this number here right here, 3 factorial? I'm getting that from my derivative. Divided by 3 factorial x minus 1 cubed, and so on. Let me simplify this bad boy. These cancel out. What does that look like, right? Well, this 2 kind of messes everything up because it doesn't follow along with this, right? So what I'm going to do is I'm going to take this part and write this in sigma notation. Let's go n equals 1 to infinity of x minus 1 to the n, right? And then I'm just going to write this 2 out here. Okay. And there's my answer. All right, there's the power series for this problem. All right, there you go, guys. Some examples on Taylor and Maclaurin series. Catch you later.